What's good, y'all? Welcome back to another video. It's early in the morning, but we got some math to do. I had someone send over some calc stuff. Looks like mainly things on limits, derivatives, things like that. So without further ado, let's get straight to it. All right. So the first question is this. They give us a function x plus 3 over x squared minus 2x minus 15. And they ask us for the types of discontinuity and where are they. Before we get into that, what are the three types of discontinuity? Well, we have a hole, we have vertical asymptote, we have jump discontinuity. In this case, the only possible ones are a hole and vertical asymptotes. The reason why is because the jump requires a piecewise function. How do we find them? Well, a hole is when the top and the bottom have the same binomials that cancel out, and a vertical asymptote is just when the denominator is equal to 0. Let's go through it. Right now it looks like I have a quadratic, so I have to factor it. So I draw my x, I take my last term, I put it on top, I take my middle term, I put it on bottom. What multiplies to negative 15 but adds to negative 2? I always think about what multiplies to negative 15 first, because there's a lot less things that multiply to negative 15 than things that add to negative 2. 1 and 15, obviously not. 3 and 5, perfect. Now what am I gonna have to do to make it add to negative 2? Negative 5 and positive 3. So now I'm going to rewrite the bottom here as x minus 5, x plus 3. So now what I'm going to do here is, well, it looks like I have two vertical asymptotes because these are both making it equal to 0, one at 5, one at negative 3. The way that I'm doing that is I'm setting them both equal to 0 and solving, but you'd be wrong there. Remember, a hole is when they both cancel out. So in this case, I'm going to cancel this one out and cancel this one out. So in other words, I have a hole at x equals negative 3, and then vertical asymptote at x equals 5. All right, question 2 here is asking us this. It gives us a piecewise function and is asking us if it's continuous at x equals 0 and x equals pi over 4. Remember, continuous means that you can put your pencil on the graph and draw all the way through the graph without picking your pencil up. So for example, if I have a graph like this, I could just do that, right? I'm just marking the graph all the way through. But let's say, for example, there's a hole here. In order for me to map the graph, I'd have to pick my pencil up and go to the other side. That dictates continuity. So the way that we figure that out is if the limit is approaching from both sides. Well, in this case, for x equals 0, this is going to be the left-sided limit because we're approaching from the left side, values less than 0, and this is the right-sided limit. So let's plug it in. If I plug in 0 for x, I get cosine of 0. Well, cosine of 0 is equal to 1. And if I plug in 0 for tangent, tangent sine over cosine, so sine of 0, again, 0 is right here because we're talking about the unit circle. Sine of 0 is the y values. Well, we haven't gone up or down, so sine is going to be 0. So the fact that cosine is 1 and sine tangent is 0 is telling me that this is in fact not continuous at that point. Let's try pi over 4. So tangent of pi over 4 is equal to 1. The reason why, well, not 4 pi, pi over 4. The reason why is because pi over 4 is root 2 over 2 for sine and cosine. So if I'm dividing by the same thing on the top and bottom, tangent's going to be 1. Well, let's see what it is for sine now. So sine 2 times pi over 4. These are going to cancel out, giving you pi over 2. Sine of pi over 2, well, that's 90 degrees. What's my y value at 90 degrees on the unit circle? 1. So in other words, I get tangent and sine equaling to 1, meaning it's continuous at x equals pi over 4. All right, next question here gives us the square root of t plus 3 over t minus 5, and it's asking us to find the domain. The domain's infinite. It's all the x values from left to right. So to think of trying to find the domain is impractical. So what we do is we think of what the domain can't be. So in other words, what can't my x values be? In this case, it's t. But regardless, t cannot be anything that makes the denominator equal to 0. You can't divide by 0. And t can't be anything that makes the square root value negative. Can't have a negative number. In this case here, I'm just going to find both of those points. In this one, I'm going to just set it equal to 0. So t minus 5 equals 0. So t equals 5. So in other words, my domain cannot be at 5. That's 1. Then I'm gonna do the same thing here, except instead of setting it equal to 0, I'm gonna set t plus 3 as greater than or equal to 0. And the reason why is because t is allowed to be whatever makes this thing 0. It does not matter. Just can't be anything more than that. I would subtract from both sides, and t has to be greater than or equal to -3. Okay, so now I have all my points, so I just have to plug it in. So for the domain here, what I have to focus on is my values. So it says t is greater than or equal to -3. That's all the values that t is allowed to be. So anything less than -3, not allowed. So my first one's gonna start at -3. I put a hard bracket because -3 is allowed. -3 plus 3 is 0. I can take the square root of 0. That's my last possible point, comma. Now what's my next thing that happens? Well, 5, parenthesis. The reason why is because 5 itself is actually not allowed to be in the denominator. I cannot have 5. I can have things infinitely close to 5, but not 5 itself, which is why I put the parenthesis. Union, 5 on the other side, infinity. The reason why I had to put the union and not just put whatever is union just kind of combines these ideas together, being like, hey, I know that 5 is not technically allowed. We're all a big happy family. This is all one thing. There you have it. All right, this question is the same exact thing, asking about domain, but now it's a natural log function. So let's kind of figure out what a natural log is. Remember, the natural log solves for an exponent. That's what logs and natural logs do. So the value right here is our argument. What number, assuming that the number in the base is positive, can't this be? It can't be negative. If I have a negative exponent, it flips it upside down. If I have a fraction, it makes it smaller. All of these things are not going to make you a negative number. So this whole thing is not allowed to be negative. So I wouldn't set the whole thing as greater than 0, right? Because I'm not allowed to have that. I'm also not allowed to have 0 as well. There's nothing that you can plug in for a fraction and make a number 0. So I would set the whole thing, but in reality, all I care about is the bottom. The reason why is because there's no x value on the top. So if this is the case, I'm going to just put x minus 1 is greater than 0. Give me x is greater than 1. As long as x is greater than 1, we're good. Because if I have anything that's equal to 1 or less than 1, well, it's going to be 0 or it's going to be negative. So horrible. Now, how do I write this in interval notation? 1, comma, infinity. Everything greater than 1. And again, soft bracket because it's not greater than or equal to. 1 itself is not allowed. So this question here is basically laying out the idea that, hey, just so you know, x cannot be equal to -2 here. Makes sense because -2 would make the denominator equal to 0. And they're saying what would x have to be equal to make this thing continuous. In order for me to do that, it's telling me that there's a hole, because the only way that it's possible for me to figure out a way to make this continuous is if I can plug a hole. So that means factor the top. So in this case here, I have x squared plus 6x plus 8. So that's, again, I can do this over here. 8, 6. 1 multiplies to 8 but adds a 6. I know 2 and 4. Bingo, bango, bongo. X plus 2. X plus 4. Look at that. It's already setting up nicely. Beautiful. Cancels out. This is amazing. Look at that. Now I got x plus 4. And I'm saying that x can't equal -2. This is still x plus 4. I don't know why I did that. But x can't equal -2, so then I just plug in -2 in this case, because let's test it now. So if I plug in -2, -2 plus 4 equals 2, being what x would have to be, or what value I'd have to have there in order for this thing to be continuous. I'd have to have a value of 2 at x equals -2 to plug that hole. Question's pretty similar, just shown in a different way. They give us a piecewise function. They say the top is when x cannot equal -6. They say b, x equals 6. They're basically saying, what constant do I have to plug in for b to make this thing continuous? Again, we're just plugging that hole. There must be a hole somewhere if they're telling me I can make this thing continuous. I gotta plug it. So the way that I'm gonna do that is I'm gonna factor the top again. So 1 multiplies to 12, that adds to 8. I have no idea. So what multiplies to 12? I'm thinking 2 and 6. Looks like I have an idea. Okay, so I'm gonna factor this thing out. X plus 2 x plus 6 over, in this case, x plus 6. Look at that, cancels out perfectly, so I have x plus 2. Now what we're going to do is we're going to plug in negative 6 here. So negative 6 plus 2 equals negative 4. So in other words, b must equal negative 4 for this thing to be continuous. All right, next set of question here looks like limits, things like that. So first thing I got here is the limit as x is approaching infinity of sine of blah, 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 blah. So it's sine, right? So which means that sine is going like this the whole entire time. So for me to find the limit, I have to find where it converges at a particular point, right? So as my x's are approaching infinity, what are my y's approaching? Well, I can't figure that out because sine's oscillating. It's always bouncing up and down. It's not converging on a particular point. So I know what you guys are thinking. What about squeeze theorem? I can't use squeeze theorem here because again, it's not converging at a particular point. I can use squeeze theorem if this was like a number. So then what I could do is I can figure out what it's going there. But in this case, I can't do that, right? Hopital's rule, I can't do that as well because this isn't 0 over 0. So there's really nothing I can do here. So in other words, this one just does not exist. All right, this question here is asking me for the one-sided limit of negative 3 over 25 minus x squared as x is approaching negative 5 from the left side. So this is one of those conceptual ideas. So let's break this down. What this is saying is we're getting infinitely close to negative 5 from numbers below it. So let's just think of numbers below negative 5. I'm thinking of negative 6. So let's think about that first. If I plug in negative 6 here, negative 6 squared is 36. 25 minus 36 is negative. So right now I know for a fact that I have a negative over a negative, which is equal to a positive. So I know this thing is approaching something positive because obviously it's not negative 6. But no matter what, I'm approaching values of negative 5 that are going to make this bottom part negative because it's going to be something like, I don't know, negative 5.1. Even though it's not negative 6, it's going to be greater than 25, but also negative. The second thing I have to think of conceptually is I'm getting infinitely close to 25. So what happens at 25 minus 25? Well, 0. But we're not allowed to have 0, and the limit only talks about things as it's approaching. So in other words, I have to think about something that's basically 0. Infinitely close to 0, but not technically 0. So in other words, I have a constant, a value that's not moving, with a denominator that's negative, but infinitely getting smaller and smaller and smaller. Look at this gap that's happening here. Oh my goodness. It's getting huge, right? Some might say infinitely huge. And that's exactly the case. This value right here is going to approach infinity, not because the value on top is getting bigger, but because the value on bottom is going to get infinitely smaller, but also staying negative. So in that case, this thing is going to be approaching positive infinity. For this question here, this is a pretty classic example of squeeze theorem, which reminds me of the one before that I really need to reiterate. The reason why I knew that squeeze theorem wasn't going to work isn't the fact that it's just going to infinity. That's a really lame answer. The reason why is because the squeeze theorem requires the bounds, in other words, what both sides are going to be going to converge at the same point. So it's got to do something like this. This one, the fact that I have an x value that's getting increasingly bigger, this thing is going to approach something. You'll see in a second. The other one doesn't have anything that looks like it's going to make it converge, make it shrink. So in other words, it's not going to bound or squeeze to anything. That's the reason why. Let me just kind of like go back to this one real quick. If I simplify that inside of the other one, it would be x over 2 plus, I believe, 3 over 2. Notice that no matter what I plug in for x, this thing isn't going to bound to anything. It's not going to shrink down or like, it's just not going to do anything. It's not converging at a singular point. That's why. This one, however, is. So how am I going to do it? Well, I'm going to take my function sine of x. And I know that sine of x oscillates between negative 1 and 1. So greater than or equal to 1, but less than or equal to negative 1. But this isn't what it is, it's x. So if I plug in x here, now I just plug in my x values. This is going to be, well, negative 1 over infinity, 0. 1 over infinity, 0. Look at that. Converging at the same point, this thing equals 0. All right, this limit here, limit of 4x to the fifth, negative 2x squared plus 3 over 3x to the fourth plus 2x to the fifth minus x to the fourth. Bunch of stuff that we don't care about, I'm gonna be honest. The reason why is because this thing's going to infinity. So all of these monomials right here with their terms, the only ones that matter are the ones with the highest degrees. Because infinity is gonna grow infinitely faster for this one than this one. So this function is gonna behave based on these. It has nothing to do with these. They're not gonna do anything, they're irrelevant. So I'm just gonna simplify this thing down to the highest degree terms, which is 4x to the fifth over 2x to the fifth. Then what I'm gonna do here is simplify. Look at this, x to the fifth and x to the fifth, they cancel out. So I get 4 over 2, which is equal to 2. That's your limit, simple enough. All right, for this question here, the first thing that I'm noticing is that the limit as x is approaching -1 is not a thing. Not saying it doesn't exist, it's just saying as it is right now, it can't happen because -1 plus 1 is equal to 0. Boo-hoo. The problem is that limit doesn't care about the destination, it cares about the journey. It's one of those people. So what I have to think about is what is it doing as it's approaching -1. In other words, I'm gonna take the limit from both sides. So the way that I'm gonna do this is I'm gonna approach this not in terms of mathematically, you could plug in numbers, but I'm just gonna think about this conceptually. If I plug in a value less than -1, well, this value is gonna be positive on top no matter what because I'm squaring it. This value on bottom though is gonna be negative. So I have a positive over a negative, so in other words, from the left side, it's gonna be equal to -infinity. All right, now let me do the same thing with a positive number. In other words, well, not a positive number, but a number bigger than -1. So let's say, -0.9 or something like that. But I don't care about that. Well, this thing's still gonna be positive on top because it's squared, cool. But this thing's also gonna be positive on bottom. The reason why is because 1 is bigger than whatever this -1 value is gonna be. So positive, negative, this thing is gonna be positive on bottom. So in other words, -1 from the positive side must equal infinity. Notice as the limit's approaching -1 from both sides, it's 2 different points. Can't find the limit, does not exist. All right, this question here is a classic example of which one's dominating. So the one before, I think it was 2 ago with the fraction, I only cared about the highest degree polynomial because that's what's gonna dictate the behavior. This is the same thing. So now I have a question for you. What's gonna grow faster? The x to the fifth when I plug in x for infinity here, or 3 to the negative x when I plug in x as the exponent? It's gonna be 3 to the negative x because infinity is the exponent. Infinity is growing infinitely, right? Exponent's already exponentially fast. This is just a constant. If you want, you can plug in values in this as well just to check, but the point still remains that if I put infinity here versus in here, this is gonna grow a lot faster because it's the exponent, it's the growth factor that's infinity, rather than the value that is experiencing the growth factor. So in that case, all I care about is this. And what happens if I have 3 to the negative infinity? Well, the negative is what puts in the denominator, so this is basically 1 over 3 to the infinity. In other words, number over massive number. You plug that into a calculator, you're gonna get something really close to 0. So if it's infinite, it's gonna be approaching 0. Right, next question here, I have a function and it's asking me to find my horizontal asymptote. Well, my horizontal asymptote is almost very similar to the limit because it's what my y values are approaching as x is approaching infinity. So in other words, it's gonna be the same exact idea where all I care about is the highest degree polynomials. So ignore. What's the square root of 16 x to the sixth? Well, square root of 16 is 4. Square root of x to the sixth is just x to the third. Again, I'm just dividing 6 by the index, which is 2, over 5x to the third. 4x to the third divided by 5x to the third, the x to the thirds cancel out, and that just leaves me with 4/5. That's my horizontal asymptote. All right, we're on to the third page of the study guide. So right here, it's asking me for the average rate of change of the function ln x on the interval from 7 to 1, or 1 to 7, who cares? So in other words, anytime I'm trying to find the average rate of change, that's the slope formula. What is the slope formula? Back in pre-algebra or algebra 1, we know as y2 minus y1 over x2 minus x1. Well, as we get older, we realize that y is not good enough, so we come up with a function. So in this case, it's going to be f of 2 minus f sub 1 over x sub 2 minus x sub 1. Well, what is f of sub 2 or whatever it is. Well, that's just my function when I plug in 7. Remember, a function is like a vending machine. Whatever is here is just your input value. It's like your money, and whatever you get is your output value, like your pop or whatever. So in this case here, I'm going to put 7. And I'm going to put 1. And then that means that this can get replaced with 7 and 1, since those are my x values. Well, now let's just plug this into our function. So the natural log of 7 minus the natural log of 1 over 7. That's not a 7. 7 minus 1. Well, 7 minus 1 is 6. And the natural log of 7 minus the natural log of 1, let's use natural log rules or log rules. Anytime you're subtracting and the base is the same as logs, we can take our arguments or rewrite them as a division, right? I can rewrite them as a fraction. So in other words, it's going to be 7 over 1, which is just 7. There you have it. All right, this one's rinse and repeat. Same exact thing. So what I'm going to do here is I'm going to just plug it in. So 5 squared is 25 with a negative. It's going to be negative 25. 5 negative, negative 5 plus 4 minus, this is going to be negative 1, negative 1 plus 4 over 5 minus 1, which is just 4. So from here, it's just combining like terms, just making sure everything's good. So negative 5 minus 5 is negative 30, plus 4 is negative 26. Minus, well, negative 1 minus 1 is negative 2, plus 4 is 2. Over 4. Negative 26 minus 2 is negative 28. Over 4. Giving me negative 7. Now this thing was asking for units. I didn't really explain that, but it was feet in seconds. So feet per second. All right, this one is my worst nightmare. I'm sorry, I gotta do it. Actually, I'm sorry to myself. I don't know, I'm just apologizing to you guys. But it's the limit definition. The reason why the limit definition sucks is because it's long for no reason whatsoever. So let's write it. The limit definition says the limit as h is approaching 0 of the f of x plus h minus f of x over h. That's the limit definition. So remember what a function is, right? The parentheses is what you're physically plugging in for x into the function. It's your money, you get output stuff. So what this is saying is I'm going to take this function, I'm going to plug in x plus h every time I see an x minus just the function over h. So this is going to be a lot of work for no reason. So let's see here. I'm going to say 2 times x plus h squared plus 3 times x plus h minus 1 minus 2x squared plus 3x minus 1 all over h. Okay, so first thing first, what are we going to do? We're going to factor and simplify everything out on this side and then do this side, just so I don't jack anything up here. So this is going to be x squared plus 2xh plus h squared. Multiply it by 2. I'm going to get 2x squared plus 4xh plus 2h squared plus, and then 3x plus 3h minus 1. Okay, now let's start combining like terms here. Can I? Please God, can I? Looks like I can't. All right, well, whatever. So subtract 2x squared plus 3x minus 1. Okay, now I can start doing stuff. Look at this, the 2x squareds are going to cancel out. All right, what about anything else? I don't have an h squared, that's unfortunate. What about this right here? Well, I have a 3x and minus 3x, those are also going to cancel out. Negative 1 minus negative 1 is the same thing as negative 1 plus 1, so those are going to cancel out. Which leaves me with, it looks like 4xh plus 2h squared plus 3h all divided by h. Well, notice they all have h terms, so I'm just going to erase every single one of the h terms. Well, at least one of them. which is going to leave me with this. But remember, it is as h is approaching 0. So then I just plug in 0 for h, and that gets erased as well, leaving me finally with just 4x plus 3. And for you guys, I hope that you guys know that if you took the derivative of this, you would get the same exact thing. So it all checks out. All right, this next one here, I'm not going to write on the whiteboard. I'm just going to explain it. It's telling me basically this. Let me pull up my computer here just so I can read it. For the function h of t, h is the temperature of the oven in Fahrenheit, and t is the time measured in minutes. Explain the meaning of h of 15 equals 420. Also explain the meaning of h prime 43 equals negative 11. The difference between a derivative and just the function is the function is telling you something at an instantaneous point. So give me a second while I reread the question. It says h of 15 equals 420. Okay, so 15 is the minutes, 420 is the degrees in Fahrenheit. So h of 15 equals 420 is telling you exactly at 15 minutes, boom, it's 420. No movement, no nothing. This was like a snapshot thing. Imagine you take your phone out, second it hits 15 minutes, take a picture, it's at 420. The other one, h prime of 43 equals negative 11, is telling you this. It's telling you, okay, again, 43, but there's movement. There's movement involved. It's the average rate of change. Derivative finds you the slope at an instantaneous point. So in other words, at 43 minutes, at 43 minutes, the degrees are decreasing by a rate of 11 degrees. It's not telling you that, hey, it is negative 11 degrees. It's just telling you that it's decreasing at a rate of 11 degrees. It's getting 11 degrees cooler. That's it. All right, this one here, I have 5 derivatives, and we're gonna kind of just run through these. So take a second. If this is your test, try it yourself, see what you get. Let's see if we get the same thing. You ready? Let's go. All right, so for this first one here, what I'm gonna do is, well, the constant is just gonna eradicate itself. Anytime you take a derivative and there's a constant, it just deletes itself. Now for this one, I'm gonna rewrite this as a negative exponent. So in other words, I'm gonna have negative 1/2 x to the negative second. So then when I bring that out in front, what's going to happen is it's going to become 2 over 2, because it's going to be negative 2 over negative 2, which again is there's 2 over 2, x, then I subtract 1, negative 2 minus 1 is negative 3. These are going to cancel out, just equaling 1, which is going to give me 1 over x to the third. Beautiful. All right, this one over here, again, I'm going to rewrite this. This is going to be 3 times x to the 1/2. So what am I going to do? I'm going to bring the 1/2 in front, and then I'm going to subtract 1 from 1/2, which is going to give me this one being 3/2 times x to the negative 1/2. Well, the negative, it doesn't actually make anything negative. It just puts it in the denominator, and then the 1/2 is just going to square root it again. So I can actually rewrite this whole thing as 3 over 2 square root x. Just kidding. I totally forgot that there's actually other parts of this, so we'll just do that next. So ignore that. Next part here is this. I'm going to rewrite this as well. It's just negative x to the negative second. So then I'm just going to do the same exact thing. I'm going to bring that out in front, which is going to give me 12 x to the, well, negative 2 minus 1 is negative 3. So in other words, this is the same thing as plus 12 over x to the third. And then this one's trying to be tricky with you, but pi is just a number. So this is all just a constant. Remember, a constant? So that's just it. All right, next one here. I have 4 e to the x minus 2 cosine x. First things first is I have 4 e to the x. The derivative of e to the x is e to the x. So this is just 4 e to the x. Now the derivative of cosine is negative sine, so that's all that's going to happen here. But the negative is, I'm just going to distribute it to the negative 2, so that's going to give me plus 2 sine x. All right, next one here, it's looking like product rule. The reason why I know that is because I have 2 functions getting multiplied by each other. So what I'm going to do is I'm going to take the derivative of the first one, t squared, which is just 2t, multiply it by the second one, so sine t, plus, and then I flip-flop, so t squared, derivative of sine is cosine, so cosine t. And then that's it, we're done. All right, last one here is another product rule. So I'm gonna do the same exact thing. I'm gonna rewrite this as 3 times t to the 1/2. And so now I'm just gonna take the derivative of the first one, I bring that out in front, and then I subtract one. It's gonna look very similar to that. So in other words, I just have 3 over 2 square root t, then just times whatever this is, so ln t, plus 3 square root t times the natural log of t, the derivative of it. Anytime you take the derivative of the natural log, it just becomes 1 over what's in front, so 1 over t, so I can actually just write this as just over t. And there you have it. I could write the ln t on top of here as well, but I'm lazy, I don't feel like doing it. That gives you all of them. On to the next. This question here is asking me to find a line tangent to this graph at x equals 1. So at x equals -1 actually. Whoa. So without further ado, let's just get to it. Ignore me. So if I want to find the point or this line tangent, I have to find the slope. The slope I do by taking the derivative. So I'm going to take the derivative of this thing, which is going to give me -6x squared plus 3. Okay, next thing I need to do here is I have it at x equals -1. So remember, the derivative doesn't find you the slope. It just finds you a key to find the slope at wherever you want. So now I have to find the actual slope by plugging in -1. -1 squared is 1. 1 times -6 is -6, plus 3 is -3. So my slope is actually -3. Now, if my slope is -3, I need a point. Right now I have an x value. I don't have a y value. That's why I'm going to plug it back into the original equation to find my point. Do not plug it in here, because we just did. Remember, derivative finds slope, function finds point. So -1 cubed is -1 times -2 is 2. 3 times -1 is -3. 2 plus -3 is -1. So I'm going to have -1 comma -1. So now I have a point and a slope, so point slope form. So y minus y1, so y plus 1, equals -3 times x minus x sub 1, or x plus 1. Now I just distribute, so -3x minus 3 equals y plus 1, giving me my final point, or my final line, sorry, and -3x minus 4. All right, a little bit of a weird one now. I have this 4 sine x minus 2, same thing, I have to find the tangent line here. Let's get to it. So even though it looks weird, I'm going to do the same exact thing. I'm going to take the derivative first. So the derivative of sine is cosine. This eradicates itself. There's nothing really crazy here. I just get 4 cosine x. Cool. But remember, this is just the key, so I have to plug in pi. Well, what is the cosine of pi? Pi is over here. Boop, right there, right? Well, cosine is my x values. It's a unit circle, so this is going to be -1. So 4 times -1 is -4. So my slope is -4. Now I need a point. So I'm going to plug it back in. So I'm going to plug in pi. I'm going to get 4 times, well, sine pi is 0, because the same exact reason, right? We're on that side there. Sine hasn't gone up or down because I'm on the x-axis. 4 times 0 is 0, minus 2 is -2. So in other words, my point is at pi, comma, -2. Rinse and repeat here, rinse and repeat. So y plus 2 equals -4x minus pi. And that's going to give me equals -4x plus 4 pi. And then I'm going to subtract 2. So I get y equals -4x plus 4 pi minus 2. Right, next one here, I'm trying to find the normal line, which is very similar to the tangent line, except it's perpendicular, which means I have to just find the opposite reciprocal of the slope. Everything else though is the exact same. So first things first, I'm gonna take the derivative of this. So I move it out in front, that's just gonna give me that, and then I'm just gonna get x, cool, then plus 3/4. Simple enough, right? Take the 2, move it out front. 1/2 times 2 is 1. Subtract, you know what I'm saying. Okay, then I plug in -3 here. So -3 plus 3 over 4. I'm going to change this to -12 over 4, which is equal to -9 over 4. But remember, this is the normal line. So opposite reciprocal. So opposite means it's 9 over 4. Reciprocal means it's 4 over 9. Equals 4 over 9. That's my slope. All right, so next thing here. I got to plug in my point. So let's go through the math together. Negative 3 squared is 9. 9 times 1/2 is just 9 halves. Negative 3 times negative 3/4 is going to be minus 9/4. Minus 4, well, that doesn't just get affected whatsoever. So 9 halves minus 9/4, well, that's just the same thing as 18/4 minus 9/4, which again equals 9/4. Minus 4. Rewrite 4 as 16 over 4. 9 minus 16, 7. So this is negative 7 over 4. And then from here, I have my point at negative 3 comma negative 7/4. My slope is 4/9. Plug and chug, baby, plug and chug. So I go y plus 7/4 equals 4/9 or times x plus 3. Okay, 4/9 times x is just 4/9 x. 4/9 times 3, 4 times 9 is 12, so plus 12/9. Y plus 7/4. I'm going to subtract 7/4 from both sides. And I get y equals 4/9 x. I don't know. So 12 times 4, that's 48. Minus 9 times 7, that's 63 over 36. Okay, this right here is equal to negative 15. Don't know how I just achieved a red marker. Over 36, and then divide by 3 on the top and bottom. Negative 5/12. That's the final answer there. This question here actually yelled at me, no calculator allowed. So, okay, geez, fine. Of this thing, when we plug in 0, well, so we have to take the derivative. Derivative of sine's cosine, so 3 cosine x. Derivative of negative 2 e to the x is just that, so just negative 2 e to the x. And we really don't need a calculator here. The reason why is because if I plug in 0 for cosine, that's going to be equal to 1, because the unit circle I'm talking about right over here, that's 1. So 3 times 1, that's 3. Then e to the x, well, e to the 0 is also 1. So this is just negative 2, which equals 1. That's it. Okay, this question here is actually allowing me to use a calculator. I'm not going to use a calculator. You can plug this in yourself. I'll just show you how to do the derivative. So first thing I'm noticing here is that these are product rules. So I'm going to take the derivative of the first one. Derivative of x is just 1. So times the second one. So sine 3x squared minus 2. That's just it. Okay, plus x times the derivative of the next one. Now this one's the weird one. Notice I have a function, sine, within a function, 3x squared minus 2. That means it's chain rule. So I'm going to take the derivative of the outside, derivative of sine's cosine. 3x squared minus 2. And then I'm going to take the derivative of the outside. Or the inside, sorry. What's the derivative of the inside? Well, that would just be 6x. From here, you would just plug in. 7 squared is 49 times 3. Well, 50 times 3 is 150, so 49 times 3 would be 147, minus 2 is 145. So sine 145 plus 7 cosine. It's the same exact thing, 145 times 42. And I could keep on reducing here, but again, it's a calculator question. You plug that in and figure out what it is yourself, but that's how you do the math. All right, next function here is cosecant of 3x at x equals 2. So this is again chain rule. Notice I have cosecant 3x and then I have 3x on the inside. It might help you a little bit. Anytime you have like parentheses like this, replace the inside with u. For those that are taking Calc 2, that might help you out a little bit with u substitution. But whatever. Anyway, cosecant of 3x. So what I'm going to do is I'm going to take the cosecant part first. Well, what's the derivative of cosecant? Negative cosecant cotangent. I remembered that because secant is secant tangent, so cosecant is just like the weird version of secant, so then that's just how I have it memorized. So I have negative cosecant. That was horrible. Negative cosecant 3x cotangent 3x. And then I just take the derivative of the inside, which is 3. So I'll just move that out in front. So negative 3 cosecant 3x cotangent 3x. From there, you just plug in 2. So negative 3 cosecant of 6 cotangent of 6. Again, if you want to figure what that is, plug it into a calculator yourself, but that's the math. All right, last question on the page here. I'll write down only the important parts onto the whiteboard, but it says use the table below to estimate the value of d prime of 120, indicate unit of measures. I'll have it pulled up somewhere on the screen here, but it's giving me seconds, it's giving me feet, and I'm trying to find, again, at 120. So remember, it's instantaneous rate of change. So if I have to estimate it, I have to estimate the rate of change. Well, the way that I'm going to do that is I'm going to take the points on either side of it and find the average rate of change. If I find the average rate of change, it's not going to be perfect, but it's going to be pretty close to the instantaneous rate of change at that point. So I have 60, 412, 180, 808. So looks like 60, 412, and then 180, 808. From here, what I'm going to do is I'm just going to take the average rate of change. So I'm just going to find my slope. So 808 minus 412 over 180 minus 60. This simplifies down to 396 over 120. I'm assuming you're allowed to use a calculator here. If you weren't though, you just keep on reducing it, but this is all going to end up equaling 3.3. All right, I have 4 derivatives here that I have to take. So let's get to it. First one, anytime you have this squared here, a lot of people get confused by this. This is like almost taking the square of the whole entire thing. So I'll just rewrite it like this so it's a little bit more obvious. So notice that this is actually double chain rule because I have the outside, which is the parentheses squared. Then I have the inside, which is also the parentheses. So first things first, what I'm going to do is I'm going to do 2 cosine of 4x. That's the first one. Then I have to take the derivative of the inside, which is cosine 4x. Well, the derivative of cosine is negative sine. So negative 2 sine 4x. I just took the negative and put it out front. Then I have to take the derivative of the inside, which is 4x, or just 4. So I'm going to replace this with negative 2 times 4, which is negative 8. So negative cosine 4x, sine 4x would be the final answer here. So also, your teacher's probably not going to ask you to do this, but notice how I have sine and cosine. So sine of 2 theta is equal to 2 sine theta cosine theta. It's a trig identity. So what I could do here is I could divide this by 2 and then multiply that by 2 to get the same thing. So I can actually rewrite this as negative 4 sine 8x. Your teacher might not ask you to do that, but I just saw it and it just came out to me, so I had to let you guys know. All right, this next one over here, I'm going to rewrite this as the natural log of x plus 3 to the 1/2. The reason why I'm doing that is because natural log rules state that if I have an argument raised to an exponent, I can bring it out front. So I'm going to bring that out front. And now it's a lot easier to take the derivative because the derivative of a natural log is just 1 over whatever's on the inside times the derivative of the inside on top, but that's just 1. So this is just going to be 1 over x plus 3, but don't forget the 2, so times 2. All right, so for this one, we're going to have to implicitly differentiate. The reason why I know that is because I have x and y in my equation. This one, all of them will stay equal to y, so y is just a function, and x is the only thing inside of it. This one, it's all mixed up. So anytime I have y, I have to put dy dx. The reason why is because anytime you're implicitly differentiating, it's because technically now y is a function of x. think about it like, you know, you're falling with time. So in other words, distance down with respect to time, I'm relating to rates. So the change in distance over the change in time, this is the same thing here. This is the change in y over the change in x, y of x. So I'm gonna take the derivative of x squared, which is 2x. I'm gonna take the derivative of 2y to the fifth, which is just 10 y to the fourth, y prime. Again, I have to put that to show that, hey, this is technically the derivative of y with respect to x. It is a chain rule. Equals 10xy. Well, that is product rule. I have two things multiplying by each other. So 10y, that's the derivative of x, plus 10xy prime. And then from here, what I have to do is I'm just gonna have to simplify. So right now I'm thinking of where I wanna bring it. I think I'm gonna bring everything to this side. So I'm gonna subtract 10y, and I'm gonna subtract 10y to the fourth y prime. So that gives me 2x minus 10y equals 10xy prime minus 10y to the fourth y prime. Then from here, what I'm gonna do is I'm gonna factor out y prime to give me 10x minus 10y to the fourth. And then I'm gonna divide everything by that. So this is gonna be 10x minus 10y to the fourth equals y prime. All right, this last one here, this is a identity, or this is just like one of those ones that you should know, kind of like sine, derivative, sines, cosine, blah, 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 blah. I'm a nerd, so I have these memorized. So what this is gonna be equal to is the derivative of the inside, so 3x squared, over the absolute value of the inside times the square root of x squared minus 1. So in this case, x is the value of the inside, so x to the third squared is x to the sixth minus 1. Again, you should probably just look these up in your derivatives identity. Just Google it and just kind of like go through these. They're all pretty similar, so it's not that hard to memorize, but the inverse ones are pretty good to memorize because it makes things a lot faster. There you have it. All right, we're coming up on the end here. We're pretty close. All right, next one here, we have 3x minus 3x squared minus 5, blah, 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 blah. I have to figure out if it's differentiable at x equals 2. If something is differentiable, it means it's continuous and I can differentiate it and the limits can be the same on both sides. So first things first, is it continuous? Well, let's see. 3 times 2 is 6. 2 squared is 4 times negative 3 is negative 12. 6 minus 12 is negative 6. Minus 5, negative 11. Okay, I'm gonna do the same thing on the bottom. Well, 7 minus 18, negative 11. So equals negative 11. It checks there. Next one, can I take the limit of this thing? Well, I'm gonna take the derivative of the top and the bottom. And then I'm gonna do the same thing, plug it in again. So 3 minus 6x and negative 9. Let's plug in 2 here. 2 times 6 is is 12. 3 minus 12 equals negative 9. This one, I don't even have to plug anything in. It just is negative 9. They're the same. So in other words, this is differentiable. Gotcha. All right. This one's pretty abstract. It's asking me, or it's giving me these two equations here, and it's asking me what constants or coefficients do I need for a and b for this thing to be differentiable. So very similar to the last one. I need this thing to be continuous. I need to be able to take the limit and it converge at the same point. So let's do both of those. Well, in order for me to find if it's continuous, I'd plug in 4. So I'm plugging in 4 for x. So the square root of 4 is 2, so I'm gonna have 2a. Okay, 4 squared is 16 plus 16b minus 1. Do the same thing on the bottom. 16 divided by 4 is 4, so 4. And then just plus 4x. And I need these things to be equal to each other. So what I'm gonna do is I'm gonna just set them equal to each other physically and solve. This is actually not 4x, this is 4b. I plugged in 4 for x, not b. So from here, I'm just gonna set this thing equal to an equation. So I'm gonna subtract 4b to the other side. I'm gonna add 5 to the other side, and I'm gonna write that up here. I have 2a plus 12b equals 5. Now the reason why I'm doing that is because What I'm going to do is I'm going to do the same exact thing for my derivatives, and then I'm going to use system of equations to find what a and b have to be. So I'm going to take the derivative of the top. So the derivative of anything square root x is just the value a over 2 square root x plus derivative of this is just 2bx. That's it. Bottom one, take the derivative of that. It's just going to be negative 16 x squared plus b. I'm going to plug in 4 for x. So this is going to be equal to a over 4 plus 8b. And then I'm going to do the same thing on the bottom here. That's going to be, well, negative 1 plus b. And now what I'm going to do here is I'm going to set these things equal to each other and get me the exact same situation like this. So I'm going to have a over 4 plus 8b equals negative 1 plus b. And I'm going to do two things. Well, first I'm going to subtract b and I'm going to get 7b. And then I'm going to multiply this whole thing by 4 to get rid of the fraction. So I'm going to have a plus 28b equals negative 4. Now from here, I'm going to bring up, or I'm going to bring down my other equation. So 2a plus 12b equals 5. And now I'm going to solve. So how am I going to solve this? Well, I'm looking at possibly using elimination. That's what I'm going to do. Yeah, I like that. So I'm going to multiply the bottom one by 2. So rewrite everything. 2a plus 12b equals 5. And then 2a plus 28 times 2, 56b equals negative 8. Now from here, I'm just going to subtract. So these are going to cancel out. 12 minus 56 is equal to 44 equals 5 minus negative 8 is equal to 13. This is negative 44. Divide both sides by 44. And I'm going to get b is equal to 13 over negative 44. So negative 13 over 44. And then from here, well, I guess I'll just plug it into this equation up here. So I have 2a. Actually, I did have a plus 28b equals negative 4. So I'm going to just actually plug it into this one. This seems a lot easier. So a plus 28 times negative 13 over 44, like this. These are going to reduce here. What, 14 and 22, 7 and 11. So 7 times negative 13. 70, 21, minus 91 over 11 is negative 4. Then I'd add 91 over 11. This is a lot. So let's add 91 over 11 to the other side. And then I would multiply this, so then it has a common denominator. Negative 44 over 11. This equals 47 over 11. Giving you your final answer of b being negative 13 over 44 and a being 47 over 11. Now we're on to the last page. All right, both of these we're going to be taking the second derivative. This one we don't have to implicitly differentiate. This one we're going to, so let's go through both of them. So this one, first I'm just going to take the first derivative. The first derivative of this is just 5x to the fourth. With anything raised to the e power, it's almost like a chain rule where I'm just going to take this thing and then I'm going to take the derivative of the actual exponent as well. So this is going to be, in this case, minus 4, because the derivative of the exponent times e to the 4x. Now the second derivative, I'm just going to do this all over again. So in this case, 4 times 5, that's 20 x to the third. And then I'm going to just do this all over again, minus 16 e to the 4x. All right, for this one, we're gonna have to implicitly differentiate. So what I'm gonna do here is I'm gonna take the derivative of y. So that's gonna be y prime equals, now this one again, I'm gonna take the derivative of y, which is gonna be 2y, y prime, can't forget the y prime on the second one, because it is a chain rule, plus 1. Now from here, what I'm going to do is I'm just going to solve back for y prime. So what I'm going to do here is I'm going to subtract 1 to 1. Well, actually, let me just subtract 2y, y prime to one side. So y prime minus 2y, y prime equals 1. Then I'm going to factor out y prime, which is going to give me 1 minus 2y equals 1. I'm going to divide everything by 1 minus 2y, give me y prime equals 1, well, over 1 minus 2y. All right, for the second derivative, I'm just going to do this all over again. So what I would recommend here is, since I have 1 on top, I'm just going to rewrite this as an exponent to the negative first. So 1 minus 2y to the negative first. And now I'm just going to take the second derivative. So this is going to be chain rule. So in this case, I'm going to take the derivative of the outside. So y double prime is going to be equal to negative 1 minus 2y to the negative second times, well, the derivative of the inside. So that's, in this case, it's going to be times, well, what's the derivative of negative 2y? It would be negative 2, but it's implicit, so negative 2y prime. So this is the key maneuver here. What I'm going to do is I'm going to just move this out in front. I have two negatives, so I'm going to rewrite this as just 2y prime, and then 1 minus 2y negative second. So then what do you do from here? Well, I already know what y prime is. It's that. So I'm just going to do this again. So it's equal to 2 times, and I'm going to rewrite it as 1 minus 2y to the negative first, and then 1 minus 2y to the negative second. Well, notice I have two things. Anytime you're multiplying numbers together and the base is the same, you add the exponents. Negative 1 plus negative 2 is negative 3. So this is going to be equal to 2 over 1 minus 2y to the negative third, or if I already put it in the denominator, to the third. That's your answer. All right, last two questions for today. We're rounding up on 2 hours here, but I have to find the tangent line of this thing at that point. So what I'm going to do is I'm going to find the derivative of this, but it's implicit. So let's take it. X squared is going to be 2x. This is going to be plus, bring it out in front, 7y, y prime equals, in this case here, it's going to be 24y squared, y prime. Now from here, I'm going to subtract 14y, y prime to the other side. So 2x minus 14y, y prime. Then from here, I'm going to factor out y prime from both terms. So y prime equals 24y squared minus 14y equals 2x. And now I'm going to divide everything by that. So 24y squared minus 14y. Right. Now, this one's a little bit different because I have x and y here. So I'm just going to plug in negative 6 and 2. So this is going to be equal to 2 times negative 6 is negative 12 over, well, 24 times 4. So 24 times 4 minus 14 times 2. Well, 24 times 4 is equal to 96 minus 28. This is going to be equal to negative 12 over 68, which is equal to, so they're both divisible by 4, so negative 12 divided by 4 is negative 3. 68 divided by 4, 4 goes into 6 one time, with 2 remaining, 4 goes into 28 7 times. Gives me negative 3/17. From here, smooth coasting, y minus 2 is equal to negative 3 over 17, x plus 6. And then for the sake of time, I'll leave it there, but you know what to do. You just do the rest of it. Last question here. I have to take the second derivative of this thing and then plug that in. So no talking, let's get to it. So first thing I'm going to do is I'm going to take the derivative of this. It's going to be 1 equals 2y prime minus, the derivative of cosine is negative sign, so this is actually going to be plus sine x. And then what I'm going to do here is I'm going to subtract sine x to the other side. So 1 minus sine x equals 2y prime. And I'm going to divide both sides by 2y. And that's going to give me that y prime equals 1 minus sine x over 2y. Now from here you have two options. When I take the second derivative, I can either raise this to negative first, make this product rule, or quotient rule. I'll just do quotient rule for today. So low d high, so in other words, 2y times the derivative of this, which is just going to be negative cosine x, minus high d low, so 1 minus sine x over, or the derivative of 2y, which is 2y prime. And then this is over 2y squared. Now I could simplify this thing, but there's no point. I'm just going to start plugging in my values. So 2 times negative 1, that's negative 2. The cosine of 0 is equal to 1, but this is negative cosine, so it's going to be negative 1. Minus 1 minus the sine of 0, which is just 0, so this is just 1. And then for this one here, I'm going to have 2 times y prime. Well, y prime, we're going to have to go back over here. So the sine of 0 is just 0, so I have 1 minus 0 over 2 times negative 1, which is negative 2, or in other words, negative 1/2. So 2 times negative 1/2 all over 2 times negative 1 squared, which is just 4. And now I simplify. Negative 2 times negative 1 is 2, minus 2 times negative 1 is negative 1, so I have 1 times negative 1. 1 times negative 1 is just negative 1. So I have 2 minus negative 1 over 4, which is equal to 3 over 4. That's horrible, but that's it for today. I hope this helps. If you guys want me to run through study guides similar to this one, always feel free to just let me know, send it over to me, and I'll do this. But without further ado, see you on the next one. Take care, and as always, peace out.